Hello, everybody, and welcome to Rocket Lasso Live. This is episode 5 of season 7. That's madness. Madness, everyone. How is everybody doing? I hope things go well. We've got Twitch, we've got YouTube. Hopefully, the audio is good, the video is good, and there's no echo. That's the goal. Anyway, we've got somebody actually had a question before the stream even started. So Vlad was on top of it. What do you think is the best way to create soft body, kind of like tearing jelly? Apparently, Houdini can do that type of stuff with grain, but we don't have grain. Yeah, that's not trivial for sure. Okay, well, I'm jumping into cinema. We're in 25.2. And I'm just trying to think of what I might do for that because it's like, well, we could do a pseudo liquid sim using like the flocking techniques, which is fun. But I don't think that's going to give you like anything jelly like. I mean, it goes to the only thing that's even kind of jelly like in cinema is in the new cloth stuff. I guess in particular, the new cloth stuff does it pretty well. So let me just show you. Let's just make a Jello cube effectively. So we're going to make a. Let's make a simulation collider, and we will make a simulation. I'm going to make a soft body, but let's build it ourselves. So I'm going to make a cloth, and let's give this some subdivision. So let's say 11 by 11 by 11, and regular cloth. If we have play, this should hopefully work fine. Hit play, you're going to see it's going to fall, and we kind of get something a little bit Jello like. So if we did stuff like let's see, balloon, we're going to give it the force of like inflating a little bit. I think is a force of 1. Yeah, the force of 1 means it's trying to maintain the volume. So already you see that it gets a little bit more blobby. And then I think we could make it a little bit stretchy, and we could make it even more bendy. So now you see it gets real kind of bouncy and squishy. And then we need to give it more structure. So the soft body, which is very different than what the old bullet system would call soft body. But if we turn on soft body, you're going to essentially get these tent poles interconnecting from different parts of the structure, creating kind of like extra bonus connections. So by adding a bunch of those in, we've added a lot of structure inside, and this might look a little funky. Yeah, see, it's very sharp right now, but I think there are additional settings. We could do more density. That's all fine. Softness, I think, is the primary thing that we want. Yeah, I think softness is the main setting. So I'm assuming a larger number means more soft. Yeah. Okay. So now this is trying to maintain the structure a little bit more. Boing. And so at this point, it's just like trying to find some balance here, or maybe we're over pressuring it a little bit. So I'll say like 1.5. So you see that's making it a little bit bigger. We could, I can cut back on some of this bendiness. We could say not very bendy, and now you see the structures there. Maybe I don't need to inflate then. And I don't have like a recipe in my head for getting like a good combination. You can see we're getting something that's kind of fun and blobby, and you never know which settings here are going to make a big difference. Soft body, I'm trying to think of any other forces that would go a long way. I'm really cranking up the softness here, but if we go up too high, I bet that's almost going to look like it's not doing anything. Yeah, that's so high that it might as well not be contributing. So yeah, this softness setting is going to be pretty important. We can make as many of those as we want. And in fact, we could do things like you could say 2 poles per point, and I see I have twice as many. And with twice as many, potentially we could make it a lot weaker because there's so many more interconnections. And you see the structure is being held a little bit more there. So it's like, okay, we're getting something kind of Jello-like. But then it goes to how would we tear this? How would we chop this in half in any way? And from there, it's like I just don't have really any clue how I might break a system like this where you would get like nice clean tearing based on I just don't know the vellum grain solutions at all in Houdini, but my assumption here would be it's like, oh well, we'd be making yeah, we just don't have that type of stickiness. I'm trying to think, because it's like we could make a grid of particles. I'll save this file just so we have it for most everyone that's going to know. But if you don't know, I'm saving all these scene files. soft body. I make these scene files, and you can get them on Patreon if you're supporting over there after the live stream. And I've been uploading them the day of, trying to keep on top of that a little bit more. So just in case somebody wants like this basic recipe I put together. So yeah, we got a little basic kind of jello-y cube. So that's cool. Now, how would I want to do this? Because we just don't have, I think we would essentially need grain simulation to do what I'm thinking, because it's like we want stickiness on the particles, and just there isn't stickiness in that way right now. I guess to just talk through a little bit of what's in my head here. Let's I don't have my particles layout here. I'm gonna load, actually I'm gonna switch my screen for a second. Jump here and let me load in. I updated my cinema, and now I need to go track down my layout particles. Open. Oh, do I have to restart the cinema? Oh no, it just, well, that's weird. It that load layout didn't. Oh, I guess, okay, I was able to click this and say load layout, but it didn't save it, so I had to put it in my menu. Anyway, I did successfully load a custom layout, which is mine. Cool. So the basics, I think I just want a, I guess we could say mesh emitter, but I think we want a basic emitter, and we can make a cube. And here's our density distribution. Let's make that larger. No, let's do a 333. So you see we get that, and I'm going to say do a one shot, and then we have a count, but there's density distribution. Constant. I thought that there was, maybe it's a shape. Maybe it's a mesh emitter I was thinking. What am I thinking of? Maybe it'll pop in somebody else's head, but I thought there was some sort of like grid distribution we could do. So it was like super clean grid of particles. But right now that this implies just a random distribution within a shape. And this grid emitter, I'm doing a shot, but I'm not seeing anything. Like, we just got count, pulse, continuous. Like, none of that means anything. So even if I were to emit these with a speed of 0, and by the way, I hate this. Under speed, they have a speed variation. So even when you set your speed to 0, you still get a little bit of movement. So you actually have to turn out that secondary one off. But if I hit play, it's going to take a second to initialize to the video card. And as soon as it does, you see, boom, we get a shot of set number of particles. But how do I do this as a grid? I'm convinced there's a way, and I'm just not sure. Cube, circle, rectangle, point. None of those. I mean, it would be in cube mode. I thought there was a way to do that, but I don't see any settings for it. But anyway, I mean, we could build a rig that would do it. I wonder if you could do it as, or if we make a matrix object. Yeah, see, that can emit as a thinking particle. It'd be kind of cool if they made it so that this could emit not as a thinking particle, but as the base particles. But I wonder if we make a mesh, can the mesh base it off the points of a matrix object? That'd be interesting. So if we move this up and I hide it, does it see that? Interesting. Like, yes, it is emitting from the matrix, but it's not. It's based on like a count I have here. So it's randomly pulling off of all of them. It's not shooting from every single one. So I'd have to essentially count exactly the number I have. And even that might be still a random distribution. I'm not sure. Out of curiosity, let's say 22 by 22. And that's what we've got there. And I don't know the math of that. So let's just go to a null and say 22 times 22 times 22. And that's how many particles there will be. Copy that. And now in the mesh emitter, I will say to shoot a set number of particles, and it will, no, that's a start frame, a shot of a constant per second. My continuous shot. Properties. I guess I still want them to move. Let's hit play. Did that? There's nowhere to put the count. So maybe doing a shot, just shot all of them? I'm surprised there's not like a percentage we could apply there. But yeah, there might be that amount. Is there a trivial way to know how many particles we have in the scene? No, I don't think so. There's going to probably be a more difficult way, but there's not a universal one. Anyway, you can see I can create a cloud in theory of all of those particles, but then it, trying to think of, I didn't even have like an end goal here. This was more of an example of the type of thing we're trying to build, which is like, okay, we've got this cluster of particles, and then, you know, this is outputting as a group. So we could put that into, you know, a volume builder, into a volume mesher. And it's like, okay, now we've kind of got our Jello cube back again, but based off these particles. And now however we build the behaviors, if we were to make the particles tear at a particular spot, but we don't have that functionality. So how would we make such a thing tear, or even just turn into a coherent blob? Like right now we could kind of turn into a coherent blob, but there wouldn't be any tearing whatsoever. So the only, even that, I don't, okay, so I just went down this whole little path here, but that's not really going to get us anywhere in particular. It's like, okay, well, we've successfully made a blob. I'll save the scene file just in case we want to come back to it. But the only thing I could think that would kind of do what is being described, and I think we still will want this volume. Don't need that. I guess we kind of will need the cube. So here's my thought is, what if we take this cube, I'll change the subdivision slightly. I'm going to chop that in half, and then we're going to drop the segments in half on that one. And we'll move this one over 50, make a duplicate of it, move that over 100, and now those are touching. So it kind of looks like we have a singular Jello blob. I know I'm not doing a fancier cut, but this is the most straightforward version of it. Now, in theory, these might be already slightly colliding with each other, so they might not be super happy. But if we hit play, yeah, you see that both of them fall, and they do seem to have been slightly colliding with each other. That might not be a problem where we can say, that let's go to surface, and collision side is only on the front. So now they would probably just kind of pass through each other, which is what I think we want. Yeah, so you see they didn't get stuck to each other, or they weren't like interlocking on top of each other. So now we get these kind of like, I don't know, these weird like airbags here. But then if we add in some stickiness, I don't know what number we need, but I'll say 5. Let's see if that actually works. Yeah, see, those are now stuck together, and see as they fall how it kind of like they actually kind of tore there. So that's kind of the effect. So if I grab both of them, the stickiness is actually not bad, and boop, and let them kind of do their thing. We're slightly pulling apart. That's fine. So then I would essentially take these two cubes and drop them inside the volume builder, and is this so accurate that that's not, aren't those bumping into each other? I mean, I think they probably are. I'm going to just, I guess, expand it. So I'm going to grab our mesher here, and we can increase that. Yeah, I'll just increase that a little bit so they kind of cross that threshold. So now you can see that at least this volume mesher is kind of treating them as if they are a single object. So change this to be our green Jello. Jello's always green in my head, although I think your most common Jello is red. That's not a good Jello green. Yeah, something kind of like that. So yeah, now we get that. And now when I let that drop, obviously it's calculating a new volume every frame, but those can actually fall and kind of tear apart from each other a little bit. And yeah, so obviously you're not getting dynamic tears, but we could kind of predetermine where a rip exists. And, you know, I mean, that's kind of what I got. We burp. Let's tilt this a little bit, just see what kind of happens. That might slide. I might make the ground a little sticky. Yeah, they're going to tumble a little bit. I mean, I do really, really like the sticky properties on the new system. Let's keep in mind, well, something to keep in mind is that if these go and they touch each other, they're going to re-stick again. Where, like, I don't think the Jello would have friction on itself, but it wouldn't, like, tear apart and then, like, reseal itself. So keep in mind that that would be a bit of a limitation. Potentially there's some crazy Vertex map stuff we could do that would somewhat work around that. But yeah, I can't really think of any way of us going much beyond what I'm doing here. Trying to think of anything that would make it kind of more visually interesting. But nothing's really coming to me. I'm going to get rid of the soft body, just see if that makes any sort of interesting difference. But yeah, I made it less sticky, so it tore apart a little bit better. But, there's so many different settings here where it's like, if that was okay tearing, let's go and throw a slightly better material on there just for fun. So I think there's a setting that you can actually get some pretty nice looking transparency. I think the redshift transparencies tend to look okay. Sort of. The refraction's obviously not going to come through, but here in the viewport at least. Yeah, so kind of get some Jello. It's kind of a little bit shiny, so you let it fall, do its thing. Blah 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 blah. Some okay tearing. Obviously, we could put more subdivisions. We could put this entire thing into a subdivision surface, various different bits. So and we could pre-subdivide that entire thing to whatever degree we need to make it look the way we want it to. But I think that is as far as I'm going to be able to go with that question and concept. Sticky cloth tear. Hello, everybody. Is Materman, first time chat. Welcome, welcome. If anybody's got questions, please start getting them into the chat. If we don't have questions, we don't have a live stream, but we do have another question here. Actually, we got two different questions. Dean, you're really good with the questions, generally speaking, but I'm going to jump to Mr. Fresh because I don't think they ask questions very often. So I'm going to pop that open, mute the tab, and we got some crazy Houdini stuff. Let me jump to the proper screen. Nope. So, assuming, this seems to be the artist. So, Ilya, is it Ilya? Oh man, that's a tough name. Ilya, is that a proper last name? Like, sounds Eastern European. Anyway, this is looking really cool and kind of crazy. Well, it goes to like this is there's so many things going on here. First of all, it is somebody's asking another grain soft body vellum question. Because there's things here that seem like they be, I mean, there's first of all a bunch of different layers here, but it's almost like we've got this active growth plus soft body plus particles layered up on top of it. Each one of those is like completely its own question. Now the growth, I mean, there's different elements for us to observe here. Like we've got these little stripes, these stripy things going along the surface, and there seems to be like some pulses and whatnot. I'm not super worried about the specifics. But the reveal might be fairly doable in using some of these similar techniques to what we were just doing. The thought, how might I do this? Because we got those stripes. I'm going to do this as straightforward as, what's a good shape? Oh, that's not out yet. There's an upcoming capsule that we would have been really useful to use for part of this. I'm going to turn off caps. Let's just see. This is going to be a little bit more exploratory, but we're going to need a bunch of subdivisions vertically, and I think we're going to need a decent amount of them horizontally. I don't want to go overboard because, obviously every subdivision is going to cost us more calculation time. And then I probably want some sort of displacement. I'm going to use the displacer, which I don't use very often. We almost always use an effector. I'm going to make a displacer, and we're going to feed in a noise, but I'm going to tell the noise to be a 2D noise. So I'm going to say, hey, you're 2D, which is a very different type of noise. X, Y. So on Y, I'm going to put 0. So now we just get these long vertical stripes. And I can change my overall scale. As I shrink it down, you can see that we can get kind of these bumps a little bit more distinct. Depending on how many rotation segments we put on there, it depends on how much detail we're going to get from them. And we need to get an appropriate scale. So we're actually seeing, like, yeah, there we go, a little bit of the uniformity. I think there's might have been like a little bit more like explicit. I'm just doing it random. And yeah, so that becomes sort of the basic shape. There could be an inside and an outside. I'm going to leave it just basic right now. And let's turn off gravity. Control D, simulation, scene, gravity 0. And let's right click and add a simulation soft body. Oh, I wanted just cloth, not soft body. Cloth. And yeah, bendiness. I'm going to increase the bendiness. Maybe we don't want to do that. And then let's make a turbulence. Keep it basic. So here's a lovely turbulence. Put the 55. This is relatively large, so I'm going to put the scale up about halfway. Let's hit play and just see what we get. Okay, so we get this cool drifty thing going around. Now, it is immediately collapsing in on itself. That would have to do with our bendiness, but I want it to be able to bend. So maybe we will activate some soft body here. And then you see that they will successfully interconnect. That will maintain some of that structure. And we could even say that these are quite soft. I don't mind them bending around. And they are slightly interconnecting. Here's the spread angle. So we could just like kind of give it this ribbing. I could also increase it more, which is going to make it more structural vertically as well. Let's just see what that does. So I'm going to hit play. Now there's a little bit more structure here. Now you see the tube is not collapsing in on itself. So the soft bodies are excellent for that type of thing. I'm going to now say that it is extra bendy. 555. Let's just see if that does anything. Yeah, not bad, maybe, but now I need to increase the strength. So let's try 222. Okay, yeah, that's a little bit more. So now that's starting to bend around. I do want it to be able to bend. So I don't want to have the strength be very high. We've got this frequency, which maybe I'll slow down. I don't think I'll make too much of a difference on this. And we can do additional forces here. But I do want it like twisting around a little bit. Now we could, spinning an awful lot. Let's try lowering down the spread so that, it's not adding any structure vertically. But I think there is very much just some natural structure there. So I'm going to say that it's got a decent amount of stretch to it. I'm going to try 5. 5 doesn't seem too strong, so I'll try 55. And yeah, a lot of stretch means it can kind of bend. Stretch doesn't just mean getting longer. It also means it can sort of compress. So that means this is just free to stretch and bend around a little bit more. So if we look at it here, you can see that we're still kind of getting our stripes. It's still working all right. And we can let that kind of dance around, twist, and kind of maintain its structure a little bit. It's bouncing and bopping maybe a little bit more than I'd want. Now, we could spend forever and try and get some really, really nice settings on that. But, if we just say, hey, that's good enough for the drifting, I might make a simple attractor here. Actually, we can just use the force attractor, which I've been saying this a couple times. I never used to use force, but now they added in a fall off type where you can just say it's a constant. The speed limit doesn't really matter. And let's just crank up the strength a bit. And let's just see, like, essentially the hope here would be that, it's, in general, if it's trying to drift away, it's going to be like, no, I want to keep you more near the middle, which hard to tell, but it seems like I did an okay job having it do that. Yeah, we do that. It's not super duper subdivided, so I feel like we could probably throw that into a subdivision surface and give it a 1-1. Let that drift again. And yeah, it's going to smooth out those lines. So even though it's twisting, it's going to still look kind of nice and stripey. It is twisting around quite a bit, but I just don't think there's much we can do about that. Maybe the soft body, we can say it's even softer because I want it to maintain the structure, but just gently. So yeah, it's there. It's able to, it's looking a little more kind of floaty cloth like. So yeah, just playing with the shape and the cloth. That's working all right. Let's give it a save. Abstract cloth drift and grow. Okay, so yeah, we've got these kind of doing their thing, drifting around. We could potentially add thickness here, but I think we'll get the thickness naturally from the volume builder that we are going to be making. Now, did I... in my head, I kind of skipped a step that's probably going to be kind of important here. The plan was to put this into a volume builder, put that into a volume mesher, and we have to give it thickness, which is not difficult. Although I wonder if we can just increase our voxel range. Yeah, see, I don't do this very often, so this voxel range is an incredibly important parameter. I should have been using it years ago. We'd have to increase the resolution, but I'm going to leave it low for now while we're doing some testing. So yeah, now we can get this kind of blobbing around doing a blob thing. As we increase the resolution, it'll maintain the original shape more. But now that we're in a volume, in theory, we could be using this to erase out certain parts of it. But in my head, we're going to be able to feed it some fields, which we can, but the fields... What's the way? Well, let me just show you. If we make a linear field here, and I set that to be up and down, we go into our volume builder. I guess I can just even drop it as a child. You see that's appearing, but I'm going to say, no. I want you to not be a box, but instead be based on the object below. And that's having an effect, not exactly what I wanted. Probably this surface threshold is going to be, no, that's just where it cuts through. But anyway, I could do something like, I want to see where there is the union of these two things, I think. Oh, no, not union. I want to where they intersect. Yeah, there we go. So now, in theory, I could take this and you can see I can just draw this on. And maybe that is what I want to do. Maybe. But I want it to be a little bit more dynamic. I was thinking maybe a spline on there would be really nice. Kind of tricky. If we had a spline, we could map the spline. If we... That's not a field. See, the inherent thing that I'm thinking would be kind of cool would be if we did that vertex map growth effect on it. But how do we make that get viewed in the context of this list? Because you can't just drag a vertex map in here. That's not a thing. And the vertex map can only sort of exist as geometry. So we could, it would kind of like limit the resolution, but it's like, this is decently subdivided. So if we, let me just show you what I mean. It'll be easier. If we make a vertex map, even on the subdivided object, and we want an other vertex map. So you can now see that's all entirely red. I'm going to drop in a spherical field and we'll just say you're starting down here. I'm fine with it starting a little bit larger there. And then we create a modifier layer and add in a freeze. And the freeze will be set to grow. And at this default value, I think we will see something. Typically, I set this to add just to make sure that even if I do some sort of reset, it'll kind of see what's coming below and continue upward. If I hit play now, and it's using deformed points, if I hit play, the hope would be, yeah, it's kind of twisting around, but you can see how it is growing. Kind of, it's even kind of able to infect itself a little bit. Now we got some additional options where I could grab, increase this radius, but then dramatically decrease the effect strength. So now it's going to be spreading in kind of a smoother gradient a little bit. And we could keep on pushing that gradient further and further. So that's kind of giving us this spreading infection. But like I said, that cannot be seen as a field. It can't be seen in the volume builder list. Fried pixels. Today I learned you can just drag fields in the volume builder. Yeah, no, it's really fun to drag them in there, and they can be added and subtracted and intersect. It's really fun dropping a noise field in there. Anyway, that's growing up, but the only way I can think to translate this over would be to physically erase out the geometry, which isn't what I want to do. I'm just gonna try. Yeah, I didn't think I could drag the vertex map in, but kind of worth a shot. We could. No, that's a little. There's things I can imagine doing. Like we could have it be creating particles slowly over time as things get revealed and whatnot. But I'm kind of thinking not of that. So this is a little bit of a blunt tool, but under MoGraph we can make a poly FX and drop this after the subdivision. And I'm going to say that this is going to transform the polygons to 0, 0, 0, and they all shrink to nothing. And then if I drop in our vertex map, you see it is now, is it all seen? Actually, I think it's inverted from what I want, which is fine. So I'll just say, there's no invert there. We could invert on the tag perhaps, but I'll just say, hey, invert the result. Maybe that's correct. I'm not sure. Actually, let's turn, yeah, the volume builder is currently off. So let's just see what this does. That doesn't seem to be spreading. Vertex map subdivision. That's coming after the subdivision, so it should be getting applied directly to it. Maybe we need. Let's not affect the scale. I'm gonna move that up just so we can see that it should be having an effect immediately, and it's not yet. So maybe we can't. Oh, what I want to do is grab this and yeah, see that spreads out like those are moving kind of a little bit oddly, but that is affecting it. And if we start scaling, like they do scale down, but it's not being seen by the vertex map. Yeah, in no way does that seem to be getting affected by the vertex map. Just experimentally, I'm going to, ooh, we crashed. All you do is turn off subdivision surface. Now we just turned off the subdivision surface with a tag on it. Maybe there's some sort of bug there. I think I saved pretty recently, so I don't think we lost too much. It might not fully crash, so let's open up the task manager. And the task, and the task master, task manager. There's cinema. Sometimes cinema crashes, doesn't like want to crash. So let's launch that again. Okay, we lost the volume builder, but let's turn that off. And let's just check out the motion here. Is it moving kind of the way we want to? Oh yeah, this is after the attractor. So essentially we're getting the motion that we were looking for. Okay, so now let's set that vertex map up again. Other vertex map. Yes, vertex map. Sphere. We'll start from the center point. That's fine. Modifier. Freeze. Grow. 25, 25. Add. And those should spread now. Okay. I'll hit save again. And now let's make that MoGraph. PolyFX. Put that after the displacer. and transform on X, and now under the field, drag the vertex map. Okay, so it's not directly seeing that. Very curious. Now let's try going under the, I'm gonna get rid of that. Let's go under effector. I'll make a plane effector, and we will move it on X, and I'll go to the field and say, okay, but view this. That also, what am I doing wrong? In my head, that should just kind of work. We've used poly effects before, and we've done fall offs and stuff. Out of curiosity, I'll use a poly effects, and I'll just drag the sphere field in there, and we'll transform. And yeah, it's only affected there. So why is it not viewing the vertex map? Delete the spherical field. The vertex map is, for all purposes, the exact same as the field. If we say view that, it's not running through. I thought that that would. When in doubt, use a connect object. Don't weld. Let's try running. Actually, I don't even need to move the saw body, so I'll just move that there. And now it is seeing the vertex map. So, you know, when in, actually there's a little bit of a feedback loop thing happening there. I am going to pull this out to operate on. Interesting. So it doesn't seem to want to operate on the object that's got the vertex map. Maybe it calculates like before the vertex map, something like that. Interesting. Now, when I put it inside, though, this creates a bad feedback loop. You see, as I move my mouse, it's kind of like refreshing. And that's implying like the order of operations is not happy with what we're doing. I wonder if we can I do that, and then that, and then this? Yes, that seems stable. Okay, so now we are creating the vertex map, and then it's getting baked down as a connect object, and then the poly effects is affecting that, and that seems to be a stable configuration. So we got the freeze. I set that to grow properly, so in theory, if I play, that is spreading, and yeah, so you see it's growing. Now, let's move our spherical field down here, just to barely catch it. And when it doesn't refresh properly there, then you want to go inside your vertex map, go to your freeze, and say clear, and then freeze again. So that's just, it's remembering the original data. It's kind of the function of the freeze is to freeze the current value. So now if I hit play, you can see that these are going to be moving. It's kind of spreading up. Now, what I actually want to be doing is not moving. I want to be scaling. So let's scale to 0, 0, 0. And now those have disappeared. Now that they've disappeared, we need to say to be outputting the opposite. So let's try putting that invert back again. Yes. Okay. So this is essentially what I was trying to do. You can now see that it is slowly spreading and infecting its way out there. And this is now real geometry. So now it's real geometry. That could then, in theory, we can subdivide after the fact. And we might want those extra subdivisions probably moving in a very kind of chunky way because we're operating on a relatively low resolution, which means there's going to be a lot of popping. So I will save this and let's rearrange a little bit. And not too much. I think we'll just yank that out, put this in the subdivision. Subdivision goes inside here. And then this stuff, the vertex map moves up a layer. So now we're just operating on the higher resolution model. Or it'll go slower, but there'll be a lot more. Yeah, there's a lot more steps it can travel. But already I can tell that it's like this is it's fairly harsh. Something that's a little bit surprising. I thought these would scale in slowly because the freeze is set to have like a 25% range. And the poly effects is just seeing that vertex map. So I would think you would see it kind of fractionally. So I thought the polygons would scale in and that might help a little bit with what I was trying to do. But let's turn that off for a moment. Feed this into the volume builder, volume mesher. Let's increase our resolution. Grab our mesher, increase our threshold. Make a churro looking thing. And reactivate I'll save it, reactivate our poly effects. Interesting. Okay, it's seeing the individual points of this, even when they're scaled down, which is just probably the way that this is interpreting it. Use mesh points, optimize and close holes. I don't know of how we could change a setting inside. You can kind of see the effect where it's like it is properly sort of growing on to fill it in. But I think that we're still seeing these points all clustered up because for the most part, I think that the volume builder is operating on seeing the points. So I think we need to thicken it, which is not amazing. This is not going to run super fast. Not that it was running super fast already. Let's disable that. And we'll take the end result of all that wackiness and we'll throw that into a thicken. And it doesn't need to be a fancy one, so I'll just leave this in basic mode because the volume should kind of read it correctly. We don't need to do the advanced one, which is slower to calculate. So if I activate that, you'll now see that as these grow, they're going to kind of pop on with volume. It's always got volume. So now when I turn this on, and the volume builder, yeah, I increased this voxel range, but if I put it back down to 0, then now it's only seeing where I actually had some thickness there. Now, here's the problem is with this entire effect is that the resolution of like the steps as it moves forward is going to be highly dependent on the steps, like the resolution of the geometry we fed in. So you can see it's kind of popping in a very sort of harsh way. So it's kind of fun seeing like this snaky tube grow on. It is quite clunky. Not the biggest fan of where this currently is. Let me think. I'll save that. Hey, everybody. DC saying that my audio is a bit low. I think it might be a bit low overall. I think maybe I'm constantly boosting it for my YouTube videos, but if I crank up the input volume, then it starts getting real buzzy. So yeah, not quite sure what to do with it. And my incoming mic for the streaming app is already cranked up all the way. Let me think. What is less resolution dependent? Okay, here's a question. Can the doesn't even make sense. Does that make sense? Can the volume builder see a shader field? So let's simplify. I just saved, so that will live on as that version. I don't think we need the vertex map or the poly effects for what I'm currently doing. So if we grab the volume builder, maybe we can grab the mesher again and increase that. Although that might cause us more trouble again. We might end up bringing back the thicken. Okay, so we got the volume builder, we got the mesher. Now, if in the volume builder, I want to make a shader field, which is a physical one, and I think this mostly works with a physical one. So if we drop this into a volume builder, it doesn't show up, which is not super encouraging. Shader field is supposed to be outputting a box, and I'm not seeing a box. Now, let's feed in some sort of shader. Put in a noise. Okay, it does show up once I make a noise. So if I set that, if I set this to be looking at the color channel of a particular material, so I want to make an old standard material. So let's hit Control B, open up our render settings, set this to standard, double click to make a material, and then set this back to redshift. Now I've got the old school material. Now I can go into my color channel and we can say make a noise, and I'll make that noise be 2D again. So now we got 2D noise, and I'll even make it, actually, no, we'll leave it kind of stretchy the way it is. So now I should be able to apply this. It's a 2D noise mapped onto the UVs of the cylinder. Now, if we go to the shader field, it's looking at the color channel of what? This material. Okay, and now let's say that the shader field inside the volume builder does not exist as a box. It instead exists as the objects below. And then I'm going to say I want to see where these two things intersect. Okay. That seems to be tiling in a not amazing way. I did set this noise to 2D, so I thought that would work. If I increase this, you can see, well, I guess I'm seeing a little less patterning, but let's try increasing that. Shader field, it's viewing noise. Let's try increasing the contrast. That doesn't seem to be propagating through the way. Yeah, this is a fairly large noise. We could make it a 3D noise, so we could set this back to regular texture. Now it's a 3D noise. And you see it shows up, but this is not. I mean, it's cool and it is there, but it's because we're back to being a 3D noise. It's just passing through the cloud of 3D noise. So if I were to hit play, we're going to be getting that same effect that we had before, but we're just going to be getting like these random patches for when it passes through the cloud of noise. They're not specifically stuck on there. Now, obviously, the effect is a lot smoother. We could increase the resolution, but right now the effect is a lot smoother, where it's not just like pop, 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 pop. It's, you can actually see them drifting around doing their thing. So it's cool, and it's a cool effect. Like, if you were to ask me exactly how to make this, it would be, that would be a fairly challenging thing to be like, oh, wait a minute, there's like all this structure to it, but it's kind of fading in and fading out. So yeah, that would be tough unto itself. But because it's not viewing this material two-dimensionally, I thought if we were applying two-dimensional materials on this, that we could kind of map and wrap our way around the geometry. To show you the thought, and this might still kind of work. If I make a gradient and set it to V, is that going to do anything? No, it doesn't seem to be viewing these two-dimensional noises, which maybe, it's like we're asking this to do some very strange things right now. Like the shader field. I've never used a shader field in the volume builder. I just kind of assumed it wouldn't work. And it seems to only work in very limited ways. I wonder, because the group field, here's a question. This would be really weird if it did. I don't think it will, but I got one more experiment. There is such a thing as a group field, and a group field is a physical one that we can drop. And can we drop that inside? And to begin with, just because I know it would work, if we put a random field in there in the group field, you see that, yes, it has shown up, and that's a random field. So we can crank up the scale on that. Let's make it something crazy like Luca. And in the volume builder, we will again say objects below and the intersection. So now we're going to see this Luca noise passing through the group field, and we can scale it up and do whatever we want, and it's going to look fine. It's going to look kind of cool. Kind of exact same. This is essentially the same setup, but we are operating through a group field, and I'm just curious if, because now it is a field, is it capable of viewing a vertex map? Because we proved the random field did. Actually, yeah, let's yoink that out. And on our, I'm not sure how far up or down that propagates. We might have to put in a few places. And let's save this as another version. By the way, everybody, if you get more questions, start getting them posted, because I think we'll be wrapping this one up soon, one way or the other. So in the group field, actually not in the group field, on the connect, I'm going to add an other vertex map, and that vertex map will just view that same random field. So now that we're seeing that random field, let's delete the random field from the group field. And now in that group field, can I drag that vertex map? Oh, it did. It does. I'm not sure for a fact, but we are viewing the field where I'm now viewing the vertex map seemingly directly in the group field. Remember, I said we couldn't drag in the vertex map, but maybe we can drag a vertex map into a group field and group field into the volume builder. I don't know, but that's intriguing. So now we kind of go back and rebuild our original rig. Okay, let's find out. So we'll drop in the sphere. That appeared. That's encouraging. Let's create the freeze. Set that to grow. 25%, 25%, and add. And that's kind of it. Let's see. Hit play. Okay. Okay, well, here's essentially what the original rig I wanted to do. And I said I didn't have a way of translating the vertex map in. And now you see it is a significantly smoother version. It's not super duper smooth, but it's smoother. And that is going to spread however we want it to. So that's kind of cool. And now I might, in this case, let's make it can just pass through it. It might kind of not be amazing, but under freeze, I'm going to drop this random field, set that to normal. And we got Perlin noise. I'm going to make it a little messier. We'll make a Luca, an animated Luca, and it'll be quite a large Luca. And that is going to be affecting. Is that just not refreshed? That blob should not be there. But it is there. Why? This is all in the vertex map. Did the group field? No, the vertex map is just seeing that. Oh, okay. When I yanked out the random field, I didn't drop it completely outside the hierarchy. It was still inside it. Oh no. Oh, okay. It's not when I dragged it. That would have been like impossible. It's when I created this, it plopped it as a sibling, which made it a child of the volume builder. Okay. Okay, so we're not dead in the water. So now I'm making, in theory, a pretty large, I'm going to make it even larger, a pretty large vertex map. And that's going to affect the radius. And now if we give this like a very large radius, now it's going to, yeah, okay. Now you see how it's like, it's essentially, I made the edges messy. So now you see it's a little bit more organically spreading out, which is kind of what I was going for there. Now, this is still going to be a little bit pop. It's going to be a little poppy as it goes, because again, it's still based on the vertex map, and the vertex map is limited to the resolution of the mesh as it goes. But that's not bad. That's a lot better. If we sped it up, essentially it would hide the effect pretty well. I think the noise is still, though Luca is such a crazy detailed noise. Like you need to make the size of it huge in order for it to be kind of a little bit more organic, and not super popping all over the place. I'm going to try and speed it up a bit, although keep in mind that our frame rate is not fast, so this would be in real time going a lot faster. It might be good to do a viewport render just for a sanity check. Let's see how that does. Save. It's always annoying. The viewport render does not take on the effects right away, so you got to copy the effects over, and then even under filter, I'm going to load the crisp preset to change those over so that we don't get like the world grid and all that stuff, which I always find very visually annoying. Okay. Yeah, it's popping a little bit. It's better when it's fast. But yeah, this is just a way of the actual geometry getting revealed. I'm very happy that the vertex map works the way it does. We could subdivide things further. Like even here, we end up with the final mesh is quite subdivided. The cloth is running on the cylinder. This is how many subdivisions that gets. Anything that we increase is going to be increasing our calculation time. Now to change the mesh, we have to go back into our vertex map and tell the freeze to clear out all that all that information. But now that already you can see, I just increased the vertical height times 3, like more subdivisions in the cylinder. And you're going to see that this growth looks a lot smoother. Now I'm going to have, that's going to have changed tons and tons of things here where it's like it's going to be slower on the cloth. The cloth is going to be bending very differently. But the whole thing is growing kind of fun and organically there. And then based on whatever the incoming original mesh is, let's go back and kind of observe that. Right now it's a little bit, it's subtle, so I'm going to just make it more extreme. We'll grab our displacer. We'll just say, okay, it's a little bit more obvious. That's got kind of that crazy shape. Everything should filter through the system as we've designed it, I think. Yeah, there it is. And now we can get that same fun organic growth going. We do different noise types and they each look different. Because we have a vertex map, in theory, those colors could also be filtering through. We could be doing smoothing. We got all these different settings inside the volume builder, this mesher. Right now this is already controlling the threshold, so I could like increase this further. We could increase the resolution of it, obviously. It could always be a good idea to throw in maybe a smoothing. You want to go simple, depending on the mesh, it'll make things smoother, but like there can be like these little pinch points. So I tend to go not too overboard on that. But yeah, you end up with this kind of like little corners of a pastry look on it, which, depending on how much we do on it, it could work, or it could be kind of visually annoying. I don't really have a amazing solution for that. But yeah, pretty lovely little growth effect there. Yeah, I don't mind that. We got a lot of things. There's so many things that this could be doing. Um, and even like a basic rig, like now we know we can actually feed a vertex map through a volume builder, which is actually that's a very important bit of knowledge for us to have. Um, the tube is not that long, so if this was a longer bit of tube, that would look even cooler. So I'm going to say 150 and double the height. And actually, yeah, let's move our cylinder to the center, and that's going to be spreading both directions. Everything I do here is slowing it down, obviously, where we got more subdivisions, which means more cloth simulation, which means more collisions. But, kind of a fun, organic-y, growth-looking thing. Let's try cranking up our turbulence. I'm going to make a smaller turbulence and have it be stronger. We could make that more uneven in theory, but we could slow it down. But I think slower is not necessarily good. I really want that turbulence to be turbulencing more than it is. Probably going a little too far on that now. But in theory, we could also be colorizing this so it could have like a different color on the edge as it grows outward. Like all the stuff could be driven with vertex maps. So we could maintain actually quite a bit of color information through the volume builder by where the vertex map is growing. And why don't we do that? Man, is this turbulence? What's going on here? There's a three-dimensional turbulence, but this thing is like barely moving. Turn that off. Turn all that off. So that's what we're feeding it. It's all maybe making the turbulence smaller and smaller and smaller wasn't helping. So maybe I should have been making it larger. Yeah, sorta, kinda. Let's give that cloth a little bit more of its structure back. Keep those spread apart. The turbulence is quite strong now, so I guess this could also be quite strong. Try and keep the thickness a little bit more. Look how vertical this thing wants to stay. That's crazy. I'm going to turn off the attractor. That's not doing it, is it? That'd be weird. There's other effects, but I thought this turbulence it could just be like the particular random seed or position of it, but it's just like, it's not a very twisty turbulence for us right now. If you didn't know, the turbulence doesn't have like a random seed, which I wish it did, but you can always just take the turbulence and physically move it because you're moving the cloud of noise. So it's almost like I've moved it to a new location, which for all purposes is like a new random seed. This does not want to not be vertical. Very odd. Oh yeah, I was going to show the material thing, and then we'll probably move on. Save. So we got the vertex map. All we have to do is kind of reactivate everything, and then I'll make a volume on the volume builder. Make a vertex color map. In the vertex color map, drag in our original vertex map. Change the remapping. Enable remapping, color remap, gradient, and let's see. Yeah, I could make it a little bit more extreme. Let's grab. I guess it's just based on the fade off, so I could change that. That'll change other things, but let's just see what happens. Load a preset. Maybe we'll grab one of my neons. Yeah, so it's kind of crazy looking. And we could potentially smooth it out as a post effect, but let's grab the original vertex map and say the freeze. Ooh, excuse me. I'm gonna make the radius even larger and then the effect strength smaller. So essentially there should be 10 steps of fall off instead of what was 4. So we'll only see the material right now if I have this selected, but now if we play, yeah, now you can see that it's the end caps that are getting affected. We could potentially grow a separate vertex map that would be a little bit more blurry and whatnot, but you can see it here that I would be able to colorize it with various means. And then this one, this is going to kind of throw some calculation time at us, but if we go to average and we increase that radius a little bit, you see that I can get a smoother interpolation of those colors based on the vertex map. But now it's averaging like tons and tons of colors. It's already relatively slow, so I guess it's not too much of a speed hit, but yeah, we could get the bleeding edge to have like this color mapping. Actually, the I don't know how well this will work, but let's say nearest, and then I think I've done this effect before, and it's always fun when it does work, is I will make a is it a delay or a decay? I'm going to try a decay. Say yes, affect the colors. And I'm going to say you have a 75% strength. So now we've got like the faster version of the calculation. Let's see if this works. Do we want it to be maybe the minimum? Okay, maybe. And some of those scratchinesses isn't. It's not exactly what I was looking for. I thought I could get those to drag themselves out a little bit more. That's not working amazingly. Interesting. I'm going to try using a delay instead, and we'll say it's a smooth 10%. Or no, is it 90%? I'm going to say 99 just to really, if there's an effect, I want to see it. And I'm just not really seeing much. Oh, I turned on color. But actually, I don't know if we need color. Oh, I know why this isn't working and why the color is blipping all over the place. This is a vertex map, a color vertex map on the volume mesher. The volume mesher doesn't have consistent data through it. So we need to do all this information calculation on the connect object. So we make a copy of the vertex map, delete that, call it vertex map 2 or 3. That's fine. And under fields, let's drag the first one. And I should be able to turn off a bunch of that stuff. And now we can just view it here. So essentially, this is the vertex map we're working with here. You see like all that lovely fall off. And now inside this vertex map that we're viewing, I should be able to grab the decay. And let's try that 90% again and just see if this vertex map will give us a little bit more of a tail. But I might need this to be on minimum, or we might need the smoothing effect. Maybe it is this one. We don't often use minimum. So it's kind of got this weird echo. All right, I'm going to get rid of the delay for now. And let's try that was the decay. This is the delay. I'm going to put smoothing. I say 99% smoothing. And yeah, that's super duper slowing it down. And actually, yeah, you see the other one is fading. So that needs a light touch. Yeah, it smooths out the gradient a little bit. A little bit. It might be actually more. It's kind of fun to play with, but I'm going to make this vertex map. We're going to put in an invert. And this is just for mapping our colors. And the reason I'm doing this is because now we've got this red spreading, and it just goes to the positive value. Is easier to keep in your head. So if I were to say, hey, here's a decay, we could know for a fact we want to use this maximum. And now if I said 90%, as this fades up, it's going to take a lot longer for this red to take back over, in theory. Maybe too long. You see how it is kind of a gradient, but it takes a while for it to kick in. But now that it has kicked in, you see we're getting pure and then almost this perfect gradient fading down to make that. And we could use this as our gradient remap source. And this is consistent. This is coherent on this particular object. As we bring in this vertex map, we could pre-calculate the averaging. So I could increase this. And as I do, the delay, that's going to stop us from viewing it. So you can see how it's kind of a harsh line, but I could say, hey, let's pre-blur that a little bit. And then we could run the decay on top of that if we were so inclined. All of that could be like extra effort. That's not strictly necessary. But now we could reactivate everything inside this vertex map. We don't need the delay because that's incoherent, but we could replace this vertex map with this one. And what's cool is by replacing it, it's viewing the vertex map, but it kept on all my color, all the settings I changed, it remembered those. So anyway, the first few frames might not be amazing, but as it goes, my hope would be that we get a better stretched out gradient. Keep in mind, I'm throwing a lot of colors in there, but it's a little bit better. That was a lot of effort for not the most amazing end results, but we can just go back to this vertex map and, change these numbers, but it's limited. Blow, turbulence, blow. Anyway, I think that's as far as I'm going to go on that particular one. It's not. We learned one really valuable piece of information about the vertex maps, but as far as mimicking the original effect, again, it goes to we got linked to a advanced grain simulation, and that's just not. We just don't have that in cinema, so we are limited in what that could do. Hey, Zach is back and Windbush is hanging out. Hey, Windbush, we gotta schedule you on the stream. Maybe like 2 weeks from now or something. Scroll. Are people okay? People are chatting back and forth. That's cool. Yeah, false knees wallpaper. Yeah, I made this wallpaper custom because I loved that particular frame. Yeah, fried pixels. Agreed. I mean, there's no real other way around it, but it does go to vertex maps, or as you say, they're always held back by wanting more tessellation, but then it kills the performance. And yeah, it's true, but it also goes to that is the very nature of a vertex map. Is it is just saying, hey, every point on this mesh now has a value from 0 to 100. So, if there's not a point, there's no place on it to get that interpolation. Let's see. Vihavana was talking about earlier about maybe using the mesh to spline on the cylinder, or a radial clone a spline line, a Mo spline, and put it in a volume mesher, and then emit particles from that surface. Yeah, it's just kind of a different interpretation of the original thing. At one point, I did think about mesh to spline, or making a series of splines somehow on that. I mean, here's just for fun, but like kind of using this same scene file as the example. I'm going to yoink that out and yoink out tons of this stuff. We don't need any of that. So now we're just left with this original cylinder, and this needs to be a way lower mesh. But inside of your assets browser, if you're in the newest version of Cinema, you should be able to search for the word. Actually, careful. I gotta be careful there. Let's search for weave, and here's the weave spline generator that Lasso made. And if I drag that in, let that load, we should be able to drop this cylinder inside, and now that's actually going to convert this into a woven pattern. Let's immediately put that into a sweep, feed in an end side, drop that down to like 2. Let's go a little bit more. Okay, so now you can see we've got this woven pattern here. Let's push it further based on how thick I made the spline. So let's say the peaks here are going to be higher and higher. Maybe we go like 5.5. Yeah, so now you see I've got this woven pattern, which is kind of fun. And then this is always a little bit of a challenge. The first of all, we might need this to be odd or even. So if I make it even, I guess there's multiple sections on the pattern. Which one seems correct? maybe that one. But essentially, we want this vertical one to be open, but we want these side ones to be closed. I'm also going to go to caps and turn those off because caps take a long time to calculate. You know, it's something, this is really, really funny. It just goes, the sweeps are very old inside of Cinema, like older than version 6 type of thing. And I have recently found in the scene file I was working on that the caps were calculating so slow because I had so many different lines that it was faster for me to take one of these caps, clone it onto the end caps from a cloner object, than actually have the sweep itself generate the caps. Anyway, a trick I can do here is say the sweep, this weave spline is going to return only the horizontal, and then this one is going to return only the vertical. So you'll see if I turn this one off that we've kind of got them separated out. And now I can grab this horizontal one here, and I'll say that this one is going to be closed. And now I can actually close that. And I think there's a additional setting. Remove last point for close. Yeah, if I turn that off, that should help with that. And now we just have to make sure we change both of them whenever we need to. And I just need to find the correct. Oh! I know why that looks weird. The weave spline is currently set to have this inset, so I got to put those to 0. There we go. That's what I was missing. Vertical. Nope, I want that one. This one. Boop, boop, boop. Okay, cool. That's what I want. Now we've got a nice weave pattern going here. So now you can see how we've made this crazy piece of geometry here, which is pretty cool. And we need to not go overboard. So let me grab the cylinder here, drop this down to about half of what we're currently doing. And yeah, now I've got this kind of woven, like finger trap looking thing, which is kind of cool. And we can now run simulation directly on this if we want. So why don't we, what's our current radius? This is currently a radius of 7. I'm going to drop it down to 5. And let's grab our weave spline and right click and add simulation rope. Make sure its radius is also set to 5. Maybe we need to do 2.5. I can never remember. And let's just save this. I guess it's kind of a continuation of the previous one. Weave rope sim. Anyway, I added those in, and now we've got 0 gravity. We still have the turbulence and the attractor. So we hit play, and let's see if it explodes. But nope. Well, I mean, it's okay. It seems to be running to itself a little bit. And yeah, now the turbulence seems really strong on the rope. So let's calm that down a bit. But anyway, you can see that this is running pretty dang well. Now, all those did seem to kind of force each other apart. Let me see. Yeah, I'm thinking maybe we do need half the radius. I'm not entirely sure, but let's say 2.5. Better. And yeah, the turbulence can take over. And then there's a setting inside of weave spline that we can increase our subdivision. So we can say subdivide, and I can say subdivide 1 extra. And now we have double the number of points. I can add a smoothing iteration in there just to round those out a little bit. And now there's twice as many points for the simulation to run on. And let's grab our end sides and increase that by 2. Just smooth those out a little bit. And just to make them stand out, let's change the color of one of these. So yeah, pretty fun and not terribly complicated to build those out. Calm all this down. The attractor could be having a decent effect here. Wow, yeah, okay. When it comes to rope, a little bit of turbulence goes a long way. There we go. Now we've calmed it down. And now I feel like some larger scale could benefit. There we go. Nice and calm now. That's what I was kind of going for. So yeah, look, we got this awesome interwoven rope thing going on. And yeah, what's cool is like these are real ropes for all purposes. Like you see that these are actually untangling from each other, and like different parts can drift away. Yeah, pretty crazy. So yeah, the weave spline generator, definitely a cool one. I dig it. Mr. Fresh, no, there is no plans to do plugins for Houdini. Fried Pixels, the reason to not put noise directly in the volume builder, the earlier file in the volume builder, if we drop the noise is not mapped onto the geometry in any meaningful way. So it would just be passing through a cloud of of noise, where the setup I was doing, it was a vertex map, and the vertex map was organically growing. And that means it's going to spread from that point. And the noise being inside the vertex map meant, even though we were still passing technically through that cloud of noise, different parts of it were growing at different rates, and it would be kind of coherently doing it, not passing in and then back out of the noise. Let's see. Is Mater Man? Can I make different size cubes align with the same separation in between? Not inherently in cinema. But there's a couple of Rocket Lasso capsules that allow you to kind of fake it, depending on what you're doing. So the first one is, I guess, partition. Yeah, partition would you let you do it. We haven't really talked much about partition in any of the live streams, but it's pretty cool. So I'm going to shrink this down and let's search for partition. So again, another capsule we made. I can drop this on there and you see it's going to be subdividing all the geometry in these cool little subdivisions. So I dig it. And we can change the cut orientation to be manual, and we can set it all to be a particular orientation. So you can see that these are all cut, and they're all cut in a particular way. We've got all this variation. So we got random density and random cuts. So you can see if we put this into like double mode, I could increase this, and you see it's always like dead even. So we could do that. And then as I add in the random cuts, you can see that they'll each kind of scale into different sizes. And then there is this gap, so I can put as much gap in between them as I want. And now that they are like this, we could make a extrude. I'll keep it parametric, so we can just say, hey, after the fact, let's extrude all of those as far as I want. And I will say create cap. And now you can see I have, now I've got the same gap and a bunch of boxes stacked on top of each other. If I were so inclined, we can take the end result of this and put that into, I usually use a fracture these days. Make a fracture, delete that out. Now you can see that these have essentially become clones, and they're going to get sent. The axis for each one, I think, is centered in the bounding box. But I could do things now like make a random, and let's grab the random. No separation on Y, but now I could say 15 offset there, and grab rotation, and we could spin them all. So now I've got a random stack of boxes entirely built based off of this partition modifier. And also keep in mind the extrude. I think we can do offset variation. So now some boxes could be bigger or smaller. So quite a bit I could do just by using that partition modifier. And we go back into partition. We could subdivide more. We could subdivide less. We could put more variation on them, less, so they're all the same size. So yeah, pretty fun to be able to do that. And I think even the random animation, I could crank that up. This could be kind of coherent. Yeah, so now you can see that they're actually animated and they're all still stacked up on top of each other. Unless I push so far that the gap disappears, then it might blip. But I could just get less gap if I wanted, or a little less of this random animation. So anyway, hopefully that opens up some opportunities in your head. But as far as manually stacking a bunch of boxes, no, sorry, I don't have a methodology for that. Not right now. And then the other method, we'll just keep this one, make a null stack partition. Scoot this over. The other option is very similar. I will make a spline, and in fact, I'll make the new line spline, set it up to Y, make it whatever height I like. I'll scoot it down just so it's kind of lined up with the other one. And very similar concept, we can make the break spline modifier. And if I drop that on, you're going to see that now I get all these little gaps in my spline. And now that I've got those gaps in spline, there are some somewhat similar controls where you can add some of this randomness in. And you see that those will randomly get moved up and down. So if I were to take this line and put that into a sweep, and into the sweep we feed a rectangle, shrink the rectangle, you see I've now made something incredibly similar. So I've now got this stack and I've got this break line, and we could put as many of these as I want, pull back, go forward, animate them, get rid of the randomness, make them even, add the randomness back in, and the exact same setup is applicable. Copy and paste this stack And I'll delete out that one and drop in the sweep. And there we go. Now they are also stacked on top of each other. This spline version is going to be a little bit cleaner. I think you have more control over it, but they both work. But yeah, to my knowledge, that is currently the only great way of doing that. I'm going to say 0 gap in between, so now they're perfectly stacked on top of each other. And I think that's kind of cool. I dig it. I dig it, dig it, dig it. I'll give that a save just for people to check out. Thanks for the question, though. 3A stacked boxes. Random. So here's another. This is maybe. Here's a third technique, which I don't know how often people would do it, but it's surprising how often I have ended up using a technique like this. So this third technique doesn't require any of the capsules. I don't know how super useful it would be, but if we make a cloner, make a single cube, shrink it down. Yep. And then we'll make it linear. And we could just make sure that they are stacked on the exact height. So it's about 41. Paste. Now they're stacked on top of each other. So now I can make as many packs as I want. Now you wanted different sizes. Now we can't get different sizes from this. But what we could do, this is where it gets weird, is we could put this into a null. I'll put it into a connect and put in a FFD. Yeah, so we put in an FFD, and it being in the connect will help here. I'll drop that down. So we just get this vertical one, and we can say fit the parent, and now don't weld. Is that working? Oh, it is working. So I might increase the scale of those a little bit, and we could put some extra vertical segments if we were so inclined. So you see I've got those. So now I could grab these points, and let's view it from the side. Let's do it from the front, actually. And now I could grab, I think this selection passes right through. No, it does not. Visible only off, select these. So I can do weird things like stretch. I can grab this and even pull it like extra far down, grab this one, pull it extra far up, grab this one, pull it up as well. And now you'll see if we view this and hide the FFD that I have now just deformed them to look like they are stacked in these different positions. And that would continue to be sort of similar, where if I steal out this random effector and we apply it, we grab our cloner, apply the random effector, we can still spin those and offset them and scale them and whatnot. And it's actually just the FFD that's scaling them. Now, I messed up a little bit here because the FFD needs to be big enough to capture the entire thing, which it's not because I rotated them. So my FFD now is not catching all the geometry. So it would have been smart to, maybe it will work. Okay, I could just make this a lot bigger. So if I just make this super huge, then it should always work. I always just grab these layers and pull them up and down. So you see if I grab this one, I can just kind of move these stacks up and down. So, a very different conceptual technique, but, can be pretty cool as well. Anyway, I'll just save that with 3 different stacks. Let's see. If anybody has any additional questions, feel free to post them. TJ's got a question over on YouTube, and I like jumping back and forth between the two. I often need a spline to travel along the medial. Is that just supposed to be middle axis of the model for the generated source or an animation path or a super system? Is there a way to generate such a spline? Oh, the medial. Maybe that's just a word and I don't know the usage. Yeah, down the middle, but the middle axis of the model. Okay, so as far as like an automatic way to do it, I can't really think of any like super duper automated way. But the problem here is that every time you get a model, like I'm just assuming it's like, oh, you're working on a video game level, or you've got all these things, like the meshes are going to be completely different depending on the situation. So there are some, let me see if this works. I don't think that would work. I am curious, but actually I'm going to, all right, I'm going to show you the basic, and actually I haven't done this so long, I don't even know how to do it. I'm not even sure I know how to do it. Actually, let's make it a little more complicated just to show the concept. So make an arc, and we'll sweep. Now, obviously, here I've already got the arc, but we're going to pretend the model we have is coming in like that. And I mean, ideally for our purposes, there'd be very few subdivisions on there. Something kind of like that. So we could do that. I'm going to turn off the caps, and let's even make a displacer just to make it a little bit harder on us, because I'm pretty sure this will work. And then we'll try it in the more complicated scenario, but I don't know. I don't know if the more complicated one will work. So I'm going to drop in the random, and we'll set this to form. And we'll just pull back on this so it's a little bit messed up. Okay, so like there's a blood vessel. Not exactly super fancy, but if I right click and say current state to object, we can hide the original one. Let's just pretend that whoever sent us the project file, this is what they sent us, and that's just what we have to work with. Man, I have not done this in a long time. If I select a series of ring elements here, under character, convert. I don't think that will work. No, convert selection to nulls. That won't work. There's like a weird. I don't think that'll work. That'll just make a single joint. There is like a function inside of the joint stuff somewhere, like inside the joint tool. But I just don't, I haven't done it in so long. I have not used this tool. What is this even doing? Doesn't seem to be generating it. It's not even, how do you even apply it? This would be modifying a joint chain I've got. I thought there was a way that you could convert like a series of ring selections into a joint chain, where essentially it's going to be like, my understanding was I would grab any given ring and find the center point of that ring and then make the next joint, and it would like draw the next one, the next one, the next one. And so essentially you could extract the midpoints of all these distorted rings. I seriously haven't clicked to this function in like 13 years or something. And I just don't know how I would do it. And I almost feel like it was the type of thing where it's like it's inside of one of these joint tools, and it was like you had to hold down like control or shift or something to make it actually get applied. And I just have no recollection of it. I'm not even sure how to search for it. Yeah. Let's see. I don't even know. I don't even know exactly how to search the help for that. Joint from, I mean, because it's not like the search here is super sophisticated. This is just gonna be like, well, where is the word joint and where is the word edge? Let me switch here. I'm just gonna do a long shot. And I'm gonna try asking AI just to give me an idea of where to search. No, that didn't. It's not. It didn't understand there. It wanted to. It's like it totally makes nonsense up. Where here it's like, oh, well, let's convert it to edge to spline. It's like that's not at all what we want. And like I said, it's so old. No, nope, nope, nope. Back again. Yeah, I feel like I don't know. This is it almost goes to like this would have to be a. I'd have to ask one of the Maxon people about it because it's so obscure. And yeah, it's just not. None of the stuff I'm seeing here is leaping out at me as the thing I'm looking for. Hmm. Yeah, that would be ridiculous. Yeah, yeah, that would be incredibly tedious. And the problem goes to a lot of the stuff converts. I mean, I'm trying to think of wacky ways we could approach this. So, okay, so let's say that we've got these edge loops and let's try converting it edge to spline. Actually, be should we be crazy and try and do it parametrically, which means I would use mesh to spline. But if we make a mesh to spline and I link to that object, then it should be converting all of that over. And now I'm going to store that selection. So we'll just say selection, store selection, mesh to spline, mesh to spline, return based off a limited selection. The selection will be the selection tag. Okay, so now we're just getting those loops. Now, we could offset. That's not going to do much for us. Can we explode these out to be separate elements parametrically? Like, could a fracture object do that? Keep in mind, we could have just done edge to spline. I'm just keeping it live. So if we say this and we say explode segments, are they exploded? We'll find out by throwing in a random effector. And yeah, they do move. So then can we, now that they are separate objects, the idea would be let's make a plane effector. And now keep in mind that here's the tricky thing is that I don't know, I think the fracture, well, actually, this will be the question. Is the fracture making the axis point at the dead center of every spline, like the bounding box of it? If so, this would do a reasonable job. If not, and the axis is offset, then it does us no good. So I'm just going to say I want to scale uniformly, absolutely. Okay, they do scale down kind of as they are. So you can see that I selected these rings and now I'm scaling those down and we can go really tiny. And then we need to, how do we interconnect those? I mean, they are separate objects. So I don't think a tracer can do it, but maybe if we make it a matrix object, this would be kind of weird, but hang on. If I make that and then we feed that, the loft is probably just going to get confused. Loft isn't very smart. Yeah, the loft is not very smart. There's no way of me creating that and turning that into geometry, which would be very helpful. Although maybe that doesn't really matter. Maybe that doesn't matter. So here's what I'm going to do. I'm going to put that back into the fracture. And now those have all shrunk down. I'm not making them all the way at 0, but they're close enough that we can kind of visually see what's going on. So now I'm even going to make them a little bit larger. So now those have all shrunk down from their center point, which was the entire point of the fracture and this plane effector. So now I think in order to do this, I'll have to reconnect that. So don't weld. So now you can see we've got all of those. So now I'm going to say the matrix object should clone onto an object, and the object will be this connector. And now I'm going to say create exactly one matrix object per spline. Now I left this larger so we could see it, but if I grab this plane effector, when we make this larger, you can see that they're all going to be created there. Now, if we were to drop this essentially down to -1, it disappears. But if we say like minus 0.999, technically it's still there, which is enough. And now these are effectively all dead center to the average of their bounding box. And keep in mind, that's bounding box, not the circle, but the bounding box. So now that those are there, we can grab the matrix and feed that into a tracer and set that to connect all elements. And then we can change that to be a B-spline with some uniform in betweens. So you see now it's actually smoothing those out a little bit. You could also maybe try something like a Kima or even a cubic, but you see each one kind of has its own kind of like wobbly thing going. A Kima might be like your smoothest version, but now you can see that if I hide the matrix, actually the tracer disappears. What? What? What just happened? I can still see these little dots. Ooh, what's going on here? Oh, I guess these are super duper duper shrunk, but that's weird. 0.9, just so we can see them. Matrix, the matrix is there. Tracer, they're connecting. Why did everything disappear? I don't understand. But yeah, so we got this tracer and it's doing its thing, and now you can see that we now have a rig that was able to make a reasonable line from all of those. And, that's not bad. Keep in mind, you could take this tracer now and we could throw it into the Rocket Lasso smooth. So I could put that in there. And now based on the smooth, I could start increasing this. Actually, I think it's very, 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 very subdivided. Let's turn that off. So now, actually, we need to just go back to this being it's linear. So you see the connection, connection, connection. Now the smooth, I'll say, hey, resample this based on step. And now I can just start adding on smoothing iterations. And I can see I can really like smooth out this line so it becomes nice and smooth. And let's see if it freaks out again. Why is hiding this matrix object making the tracer disappear? That is the most bizarre thing. I mean, fine, I'll just shrink the matrix down. It's just visually annoying me, so I'll shrink it down. But, very odd. So anyway, now we've got this nice line going all the way through, and it did a fairly good job of that. Now, so yeah, now you didn't have to manually scale them down, but we did have to make those loop selections. The problem is I don't think that this will scale to something more random. Line down the middle. We could bring back our original geometry. Now you see that we should have this line that's doing a pretty dang good job of traveling down through the middle. Now, one of the reasons I think this worked is because edge to spline and mesh to spline know that the point order here was like 0, 1, 2, 3, 4. It knew that, but barring not knowing that, I don't think it would do as good of a job. So let's create a scenario. Yeah, let's create a little bit of a scenario here with like a goofier setup just to see how far we can stretch it. I don't think this is going to work. What? This is so annoying. There's another capsule coming out that would help with this process that I think would make this work, but it's not out yet. And I can't say any more than I just did. I'm going to make a ricochet. The ricochet is going to see the cube. The cube is going to get hidden. And now I'm going to have the ricochet go ping, 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 ping. Actually, we just go 1, 1, 1, 1, 1, 1. Okay, cool. So we get all those doing their thing. Okay, ricochet. Let's copy the smooth. Drop that inside. Get those a little bit more rounded. Cool. I just want some chaos splines. We can make that editable. And I guess it doesn't have to be editable. Let's throw that into a volume measure. Put that into a volume. Put that into a volume builder. And some of these are going to be blobbing into each other. So essentially, this is the scenario I want to tinker around with. Is like now you've got this kind of like crazy looking thing. So let's do another current state to object. Keep the original just so we can go back to it if need be. So I can't make easy loops, but in theory, it's like, well, we could kind of go around and try and find things that kind of loop okay. But you could also manually make loops. So, some of those are okay loops. We could make more of them. But you can just hit UM, which is the path trace. And here's where things would kind of get interesting. It's like, okay, I'll kind of make, let me change this to be a live path. So I could say, okay, well, here's another one that's traveling through a particular location, even though the geometry is not super duper clean for us there. Yeah, even there, look how far away those connections would be. So anyway, you can see I've made a couple of those, and we can say, okay, it's supposed to continue along this path. Maybe I can sneak in a few loops. Not so much. Do want to push it a little bit further, but I still don't think the order of operations is going to work so nice. Again, even with what we're doing, we're trying to make it as fast as possible, but sorry, the camera angles are difficult. We're trying to make it as fast as possible, but this is still an incredibly tedious process. But at the same time, it's like, well, how would you do it otherwise? And even that could be even more tedious. So let's just say that that's our arc. This geometry is chaos here. Now let's try duplicating our previous rig, which essentially is this entire thing. Copy paste. Don't need the sweep. And this time we're working from these. And we need to store our selection. Store selection. And exact same deal. Mesh the spline. View our volume mesher. And it's exceeding the point cap. I'll just say override. And now it's converted all of them. I will say limit to the selection. And the selection will be the selection. Now we can hide. Actually, I think there's a button for that as well. Boop. Actually, no, let's not do that. Let's hide sources. Well, I'll hide that. So now, well, now you can see the entire rig is propagating through. You can see that those are the lines. They are indeed getting shrunk. But the problem I thought would happen is happening, which is the point order is not a particular point order. So it's like, oh, first, second, third, fourth, fifth. So there's nothing to tell those like what order should they be in, and there's no guidance. The fracture just does what it does. It's doing it based on which point it was the smallest point in any given segment, and then not. I don't think it'd be any better, but yeah, it doesn't. Nothing's going to change this point order. The Voronoi fracture has. I don't think maybe Voronoi fracture might not actually even work with splines. Get rid of that. But is it even able to explode them apart? I'm curious. Transform effectors scale. No, see, okay, the Voronoi fracture can't even do it. The Voronoi fracture, the only advantage here is it has sorting, but if this was geometry, which it's not, we could sort the result by like X or Y or Z, or distance to an object. So in this case, it's relatively clean. So we could put a null here and then they would reorder them in the proper order. But if it like twisted around, then as it got closer again, they get back out of order. So keeping that super parametric is not super duper an option. So yeah, we see the line is connecting from boom, 1, 2, 3, 4, 5. So that kind of stops us dead in our tracks as far as doing that super duper dynamically, as dynamic as I could think to do it. I'm trying to think of a handy way. Yeah, it's all going to be pretty time consuming. Like I said, there is an upcoming tool that would have made this sequence be correct, but it's not out yet. And fracture. Yeah, the fracture is enabling us to clone onto them. They're already cloning on the surface. It popped in my head. This doesn't really help us here, but we could plop this mesh the spline into another smooth, put that into a different smooth, and especially if I were to like resample them, and I'll do a smooth edge, and I guess we tell them to, I guess it's open, which means it's open. I guess, yeah, it's, this has no way of closing them. But anyway, the smooth, if you put enough iterations of smooth, then they kind of shrink down to virtually nothing. And we could stop it from disappearing by keeping this minimum length. And you can see that you make them really tiny. So I'm kind of parametrically, without needing the matrix object, making them shrink down super duper duper tiny. So that would be like kind of a thing, but it doesn't change the point order problem. Um, we could also use a trim spline, which would trim all those down to be a set length, which, you know, would also be a way of getting it small. I'm trying to think of a way of reordering. I mean, obviously, you could manually you could make it editable and manually reorder them to make sure that they're in the sequence you want, but that's not amazing. And then I don't know if this does anything for you, but if we reactivate, oh, I need my cube. So we got our blob here. I don't think that this would be. I don't think it would be amazing. I'm trying to think of other ways to go about doing it. Because a placement tool, like if we made a sphere, I don't think the placement tool is that dynamic. I'll just make it kind of a bright color so we can see it easily and then shrink it down. So if we turn on I don't use it very often. Dynamic play, yeah, I guess just the place tool. So you can see I can move this and it's actually going to do a, or is it not? Normal key, prevent collision. It's seeing the cube. That makes sense. Okay, so you can see I could take this and I can place the sphere around. But the placement tool, yeah, it's just colliding. It's just colliding with the geometry. So that doesn't help that much. If we could occlude, I don't even think, is that even an option anymore? Do you remember like the old occlusion? I don't even think it's a thing anymore. I can't think of the last time I thought to occlude. I never honestly used it. But it's like if we could make it so that all of the geometry facing the camera disappeared, and what I could do is shrink the sphere to be the size of the pipe essentially, and then place it inside. But like we're running into all sorts of like kind of limitations there. I guess if it's on the placement axis normal, there's an offset. So X, okay, maybe that could do something for us. If these tubes are somewhat uniform, that is up. So maybe we need to go positive. No, that's out. So we want negative. Yeah. So if I made the sphere the correct size and we do the correct, yeah, you see now it's kind of placing in the center. And then if you hold down control, you make a duplicate. So if I kind of eyeball this properly, I could kind of place as many as I want, and each one is being created in sequence. So you see, I'm actually pretty rapidly placing these pretty near the dead center. And of course, curves, you'd want to like add more of them. But yeah, now I've made a sequence of those. Not bad. Each one's created as an instance, which I guess doesn't matter too much. So now I think if I just select all of them and make a tracer and say connect, don't trace the vertices, hide. Yeah, now I've got that line. Let's make a null. I can hide that. And now I've got that line there. And I was able to drag and copy, and manually place pretty quickly those spheres. Now, obviously, that's not perfect for like if the blood vessels or something were getting bigger and smaller, obviously the placement would be more tedious. But that's not bad. And now that we got the tracer, we can do all the things we're already doing. Like I could throw that back into the smooth and I will subdivide. We can smooth it. So that's kind of chunky. I could smooth it a little bit and keep in mind, or we also have counter scale, so I could counter scale that. So as I smooth it, it's trying to maintain the shape a little bit. Honestly, we probably need, oh, that's subdivide mode. I meant step mode. So yeah, now we could take the edges off there, and counter scale is still kind of smooth, but hopefully kind of in the center of that. So if we did this, now we can create let's just see how well this worked. I'll make a camera. I'll take the point of view of the camera. We'll make an animation align to spline. The rocket smooth will be the spline. We'll say tangential. I'm now inside the tunnel, and we could subdivide it more if need be, but now I can just grab this and slide. Not bad. That's maybe the fastest way I have ever thought to do that. I was able to keep everything parametric. Well, I didn't have to make anything editable because we're just using the placement tool, and we could just place and go plop, 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 and put everything we want. If at any point you didn't have the resolution you wanted, you could just drop in the next one in sequence. It's even possible that if we did this with like a series of like polygons, that we could just keep plopping things into like a connect object, and they'd all automatically work for the smooth. I'm sorry, for the tracer. Yeah, so I think that would kind of work. Yeah. Yep. That's what I got. We got something better than I thought we'd be able to. I'll save it. B, line down the middle. Oh, yeah, line down the middle, but I always mark the plugins I used, or at least when I remember. So this will use Racket Smooth and Rico, I guess, RKT Ricochet. Save. What time is it? I haven't even looked. Oh, wow. We're 8 minutes from the end. My cup was blocking the clock. Phil. Well, let's see. People were throwing out ideas. I didn't really look. Tobias saying, would emitting particles from the splines, the fractured splines, be centered? Emitting particles from the splines? No, that would just emit from the spline, like from the actual spline itself, not like the center of the spline. I wonder if there would be a... That's another idea, though. I mean, depending on the way the tube... Oh, I guess maybe it wouldn't work too well. The thought was, what if we ran a stream of particles? Of course, I'd be colliding with all the geometry. It'd probably escape. It'd be slow given this geometry I have. And it also goes to, we need the particle to be kind of fat in order to travel through. So if it ever got too skinny, it wouldn't, and it'd be kind of bouncing. But then we could also do that smoothing afterward. Probably not a great choice because like it could get, it's like the particle could like bounce off that and not go where you want it to go. So you'd kind of need a guide spline to guide it. But the whole point is making the guide spline, so that wouldn't really help. And then Phil said, what if you ran another ricochet through the geometry and grew a rope radius? Oh, I see what you're saying. Oh, sorry, Martin. Yep, we're wrapping up. Phil, again, like that's a funny idea, but the ricochet just couldn't be counted. It depends on what it is, but it's like if the whole point here is like we're traveling through the center of a sewer pipe, that we could make a ricochet, and the ricochet could be bouncing around inside. But it's like the ricochet again could bounce off that and go right back down the tube. And even if we offset the surface here, so it worked pretty well, and we got the spline bouncing, like it wouldn't be very art directable. We'd have to like it bounce here, and it, like I said, we could make the tunnel relatively skinny, using ricochet itself, where we could like kind of be bouncing, kind of like zigzagging here, bang, 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 and the smoothing could clean that up. But it's like, so if you had one little pipe, let's just go to show you. So of course here, the premise here is that we don't have a ricochet to give us a spline, because obviously right now we do have a real spline here we could be referencing. Let's shorten this up. until it kind of overlaps itself. So yeah, we'll go to about there. So that's a pretty long spline. And let's say that, you were getting this and it was already made editable. So yeah, like we don't have that nice geometry to work from. Just for fun, if we were to make a brand new ricochet, and it's even starting from the right spot because that's just where we started. Of course, I could just wiggle this a little bit to make sure that like we're not getting any kind of cheat from it. So let's say ricochet is referencing an object, and the object is going to be the end result of that geometry. And let's hide the source so you can kind of see what's happening right now. So you can see it's already like it's just kind of bouncing all over the place. And it's like, yeah, eventually it might sort of make its way out, but also might travel halfway and come back. Now we can dramatically improve our chances here if we start saying align to the surface. So if I start cranking this up as we strike the wall, and as I increase this, actually, it's like some of these are getting okay to the end. You see that guy did an okay job of getting there. But yeah, there's still some chaos here. I'm gonna get rid of the randomness, and if we tell it to align to the surface, yeah, so you can end up in these situations where it's like it kind of arcs around and it starts spinning around, and you just kind of get trapped. So there's actually a lot of randomness involved here, where it's like that could happen and it can escape, and it all makes perfect sense from what we're doing, but there's nothing to guide it. So it's like here, I just kind of coincidentally got a combination that worked good. A different seed, a different angle, a different anything could have messed that up. I could trim this back, and now you see it's done an okay job of getting to the end there. And then in theory, but even here, if we went to smooth this out, it's going to be smoothing out, and it's probably going to be cutting all the corners, which would kind of negate the purpose. Then but there is a feature inside of Ricochet that might help here a little bit, but it could also create a lot of trouble, or it might not work. But inside of Ricochet, I can go to modify, say visualize, and we can add in some surface offset, and I can shrink this in so you can see what I'm actually doing. It's very subtle, but you see all these points. It's like the original points there. And essentially we're just doing the secondary extrude and pushing the points away from the surface. So it's a little hard to visualize, but yeah, if I move here, as I rotate around, you can see what's happening is I'm shrinking the tube down. So we could keep on shrinking the tube down, but you got to keep in mind that you could end up with like polygon intersections and whatnot, which could create trouble. But as I make it thinner, it's kind of being forced to travel down like this thinner pipe. But if you go too far, you see even here, like some frames, it just kind of comes back. But in theory, that's like a thinner, more accurate link. Yeah, and somehow it's doing a pretty dang good job of making its way through there, like fairly consistently. But now because we're traveling a little bit more through the center of the pipe, that is going to be a little more susceptible to getting smoothed out nicely. So I could then put that back into a smooth, and we will resample step. And then we can add as much smoothing in there as we want. I could try counter scaling, which usually works pretty well. So with us only having that raw geometry, we did a little bit of guessing, checking, wiggling some stuff around. The line's a little long right there, but yeah, that's not horrible. And if we were to do the same deal again, let's unhide our baked geometry, tell the spline to link to the smooth, drag that back, and let's go become the camera. So now as I increase this, let me turn on some polygons there. Whoa, whoa, whoa. So not bad, not amazing, but not bad. We're able to travel through there. It didn't escape through any edges that I could tell. But obviously there's some limitations there. But we lucked out and we were able to get a sequence that worked pretty well. So yeah, I'm actually kind of impressed that we got a line that looked as good as it did. Let's see. Lignazio, thanks for subscribing for the 37th month. That's crazy. That's some dedication. I appreciate it. For the whatever pennies we get from Twitch, they're all coming from you. So I appreciate it. Let's see. Zach saying, could a normal move be used to shrink down the supplied tube and then the matrix clone onto the surface and then trace? I mean, given the tube I have here, yes, maybe. Even goes to given the geometry we see, because the matrix or the move thing is a very particular configuration. But if we drop in the smooth here, and I put in enough kind of, no, see, it pinches it in too much. Like, see, that does a pretty good job of making it skinny. It's not bad. Oh, but then you said matrix clone on the surface, but the matrix clone on the surface won't work because the matrix clones will be totally random. They're going to pop all over the place. So there's no particular order to those, unfortunately. But yeah, you could kind of shrink these lines down, and that might be doing an okay job of pinching those down. But you see on these curves, and again, it's like, oh, well, what happens if you're putting this in the middle of a sewer with a completely different type of geometry? Um, you know, different limitations all over the place. The smooth technique, kind of works to shrink that down. You could also, the normal move you're talking about, like the way I would kind of do the parametrically is we can drop in this point. I'm going to say deform the polygons, and let's not deform on Y, but you'll see here that if I change this Z, I'm grabbing each polygon and moving by its normal, so we can inflate, but we can also deflate. So I can keep on going. But you see that this essentially will end up with exactly the same type of limitations that we were just getting with the smoothing. So here it's like, okay, that's about as far down as I could go until it starts like getting crazy craggly on top of itself. But this still doesn't give us much else. Yeah, because the sequence doesn't mean anything. And we have totally random geometry. It's fun coming up with different techniques. And it even goes to this, obviously limitations here, but it's like, we've got this tube here. If we were to feed this into, I don't know how good of a job it'll do, and obviously it depends on the mesh, but if we throw this into a remesh, I imagine, yeah, you see, it does a pretty dang good job of converting that to a pretty nice looking mesh. So, now that it's converted that mesh, this will probably do a slightly nicer job of the plane effector, deforming that to be a little more pinchy, which is kind of getting it a little bit more near the center. But you'll see that it's like, even this is not perfect, where it's like, yeah, these are more near the center, and maybe we could do a single edge to spline. But once we get to any area that was not perfect, like this, that edge to spline won't make that curve. So you'd have to make multiple selections. Maybe it would still speed you up. So not a bad option, potentially. And if we're going along those lines, we're just exploring different possibilities here. I'll keep that existing just in case. So we got that remeshed in this particular other instance. I'm not going to save every one of these. I'm going to try. That's pretend this has been baked down. So this this is just a. Ooh, what's it doing? This is just a mesh. So if we were to say, well, okay, let's take that and feed that into a volume builder, and then feed that into a volume mesher. And essentially, we're just trying to get really, really skinny, clean geometry. So in this case, maybe we could say that we're going to crank up our resolution significantly. So now there's quite a bit of subdivisions on that. And now could we, that's an entire volume. If we grab the builder and make a dilate in a row, that's going to inflate. But if I offset it negative, then it's going to shrink. And now you can see I'm shrinking it, shrinking it, shrinking it. And depending on our resolution, you can see how small I might be able to get that. So again, now we've got a relatively skinny one. I don't know if it's perfect everywhere. Some of these might have shrunk too much. But now we got a very, very skinny line. And then what if we remesh that? Remesh. I mean, I would think it'd be similar to what we had before. It's a little chunky as it goes around. But yeah, we could potentially get an edge to spline. I also could go to the ricochet, might do a better job of traveling this down like the center path. But yeah, you see there's even here, like that area got a little squished. So potentially it's like, oh, we want to actually drop our voxel size even smaller so that it can actually build a better tube there, and then it gets remeshed. The remesh, we could say drop that down to only 10% of its original polygons. In theory, that should make a smoother path overall. So that's now successfully given us a skinnier tube that we can now use all those same techniques we were talking about. It might do a better job of getting us there. But again, it's very, very dependent on the incoming geometry. But, just out of curiosity, if I were to make that proper editable now, and we try and just do a single, Actually, I'll just for simplicity's sake, I'm going to only keep the inner chunk of this line. So I'm going to hit UW. Nope, UW is connected. What is the fill selection? UF? Yeah, UF. Grow, invert, delete. Now it's essentially an open, these have open caps. And the only reason I did that is now I can say UL for loop selection. And now you can see I can click there. And now I did, given this setup, I did get a line that made it all the way to the end. So now if I say edge to spline, we did get a pretty nice looking edge. Let me hit undo a few times. Copy, undo, undo. Okay, so now we go back to the one that was just called mesh, and I paste that in, and now that's the new spline. So let's again, we'll do a camera check. I'll link to that one, link to the camera, and now you see we're inside of it. It's gonna be a little choppier because we're not smoothing it, but you can see that this is doing an okay job of traveling through the entire tube, and it's not perfectly, but it's pretty near the center of the tube, and that traveled pretty well. Oh yeah, I brought the original one back. Anyway, that's a bunch of different potential techniques, but there's not a universal technique there for sure. Every single one of them had their limitations, but if nothing else, that is a bunch of different techniques that might be applicable. Yeah, very, very good question. Like going to super duper basics of modeling and type of thing I could imagine people needing to do, and that thing would be incredibly tedious to do. So, yeah, not bad, not a bad one. I'm trying to think of anything else that would potentially work there. Yeah. So many techniques that pop in my head. It's like, oh, it'd work, you could kind of do something if we had a spline, but it's like the entire point of this is making the initial spline. I'm not sure how messed up this thing is going to be, but I'll just save this file. I didn't, we just did a bunch of things and we weren't really documenting it as we went. But let's see, I think we're probably over time. Yeah, getting 10 minutes over time. I super appreciate everybody coming and asking questions. Next week should be another regular episode, which I'm looking forward to. Tobias, thank you so much for putting the link to the Rocket Lasso community page. So if you're not already part of the Rocket Lasso community, go ahead and head to that link and you can join the Slack channel, which is actually really useful, where you can go and talk to other artists, ask questions, post your work. And also I post in the live, there's a live channel where I'll at the entire channel. So if you want to always get notified right when I'm starting, that's a great way of doing it. Anyway, that I think is going to wrap this one up. Thank you so much, everybody, as always. But where's the button here? I got too many different layouts now. But anyway, I super appreciate everybody coming and hanging out, asking questions as always. And we got some exciting plugins going on over here, which I'll be excited to show off once they are ready. But I think for now, that'll wrap everything up. Thanks, everybody. See you next week. Bye.